Okay, so we want to determine the x and y intercepts, the vertical asymptotes, and the horizontal or slant asymptote, and then sketch the graph of the rational function f of x equals negative 2x squared plus 4x plus 6 all over x minus 2. So the first thing I'm going to do is factor my rational function to see if anything cancels out. So in the numerator, I see everything is divisible by a negative 2. So dividing everything by negative 2, I get x squared minus 2x minus 3 over, my denominator is just x minus 2. It's linear, it doesn't have a GCF, so I'm going to leave it alone. But now the quadratic that I'm left with in the numerator, x squared minus 2x minus 3, it does factor. So I have negative 2 times, this factors into x minus 3 and x plus 1 all over x minus 2. So I see that nothing cancels out. Since nothing cancels out, then I know from the denominator that I will have a vertical asymptote. So I'm going to go ahead and figure that out. My vertical asymptote, I'm going to take the denominator, set it equal to 0, so I get x is equal to positive 2. There's my vertical asymptote. From there, my y-intercept, I'm going to go ahead and figure that out. The y-intercept is what I get when I plug 0 in for x. So I'm going to set x equal to 0. So I'm going to get, I can either do it from the unfactored form or from the factored form. I'll still get the same value. It looks easier to plug it into the unfactored form, so I'm going to put it in there. So I'll get negative 2 times 0 plus 4 times 0 plus 6 over 0 minus 2, which gives me 6 over negative 2, which is negative 3. So now I know my y-intercept is 0, negative 3. That's my y-intercept. And we can find our x-intercept. This is what we get when we set y equal to 0 or set the function equal to 0. So here I'm going to take the factored form and set it equal to 0 because I'll have to factor it anyways. So I have negative 2 times x minus 3 times x plus 1 over x minus 2, and I'm going to set that equal to 0. So we are just solving a rational equation. So I'm going to multiply both sides by the common denominator, which in this case is x minus 2. On the left, my x minus 2 cancels out, so I get negative 2 times x minus 3 times x plus 1 equals x minus 2 times 0 is just 0. Now I already have my equation in factored form, so I can just take each piece and set it equal to 0. So I can do negative 2 equals 0. We know that's not true, so I don't get anything from that. X minus 3 equals 0, so I get x is equal to positive 3. And x plus 1 equals 0, so I know x is equal to negative 1. So my x-intercepts are 3, 0, and negative 1, 0. These are my x-intercepts. So what do we have? We found the vertical asymptote, we found the y-intercept, the x-intercept, and now I need to figure out, does this function have a horizontal asymptote or a slant asymptote? So remember, with the horizontal or the slant asymptotes, we're looking at the highest exponents. So in the numerator, my highest exponent is a 2, and in the denominator, my highest exponent is a 1. Anytime the numerator has a higher exponent than the denominator, we automatically know that we have a slant asymptote. And to find the slant asymptote, we're actually going to perform this division. Since I'm dividing by something linear, I can use synthetic division, but if what we were dividing by was a quadratic or a cubic or anything higher than a linear function, then we would have to use long division. So to streamline it, I will just use long division to find my slant asymptote. So let's come down over here. Nope, I lied. Let's go to another page. So I'm going to find the slant asymptote. Again, I know that I have one because the exponent, the highest exponent in the numerator is larger than the highest exponent in the denominator. So I'm just going to divide my function. So we're dividing negative 2x squared plus 4x plus 6 by x minus 2. So x minus 2 will go on the outside. And negative 2x squared plus 4x plus 6 will go on the inside. So if I multiply negative 2x times x, that'll give me negative 2x squared. So negative 2x goes up top. Now multiplying negative 2x times everything on the outside, negative 2x times x gives me negative 2x squared. Negative 2x times negative 2 gives me positive 4x. Put that in parentheses and subtract. Negative 2x squared minus negative 2x squared cancels out, gives me 0. 4x minus 4x cancels out, gives me 0. Bring down my next value, so plus 6, which is just 6. Technically, the exponent on 6 is x to the 0 power. Once I get to a piece that has a lower exponent than what I'm dividing by, I know that this is now my remainder. So when we're talking about a slant asymptote, the remainder really doesn't make any difference. I know that this is my slant asymptote. So y equals negative 2x is my slant asymptote. So we have all of our pieces now. So I'm going to go ahead and start graphing this. So I have that my vertical asymptote happens at positive 2. So I'll put my vertical asymptote at positive 2. My x-intercepts are at positive 3 and negative 1. Those are my x-intercepts. My y-intercept is at negative 3. 1, 2, 3. And my slant asymptote is y equals negative 2x. So I'm actually going to graph that line. So I know 0, 0. And if I plug in 1, I get negative 2. So right about here. Right there. And if I plug in negative 1, I get positive 2, about right here. So there's my slant asymptote. So by the way my points are, I see that I obviously have to have a piece of my graph over here because of this x-intercept and a piece of my graph over here. But we're going to look at what my function is doing on either side of the vertical asymptote, just to be sure. So I want to see on the right side of my vertical asymptote, am I actually going up to positive infinity the way that I think it should? So I'm going to take a number that's just slightly larger than my vertical asymptote. So recall my vertical asymptote is at positive 2, so pick a number just a little bit bigger than positive 2. I'm going to take 2.01, and I'm going to plug that back into my function. I can plug it either into the original or into the factored. I'm going to plug it into the factored. I feel like that might be a little bit easier. And all I'm really looking for is the value I'm going to get. Is it positive or is it negative? And that'll tell me, am I going to positive infinity or am I going to negative infinity? So I'm going to plug in 2.01 to the factored form. So I get negative 2 times 2.01 plus minus 3 times 2.01 plus 1 all over 2.01 minus 2. So 2.01 minus 3, this would give me a negative. Negative 2 is negative. And 2.01 plus 1 would give me a positive. So on the top, I have a negative times a negative, which is a positive, times a positive, which is still positive. So I know the numerator would be positive. And 2.01 minus 2 is positive, which gives me a positive number. So my assumption is this is going to positive infinity. So I know I'm going to skate really close to my asymptote as I go up. And then I have to come around and skate across that asymptote right there. All right, so my assumption again on the other side here is that I'm going to skate across very close to my slant asymptote and then go down to negative infinity. But again, I want to kind of validate that. So I'm going to look at the left side of my vertical asymptote. So now something just a little bit smaller than 2. So I'm going to say 1.99. I'm going to plug in that value. Again, I like the factored form and see if I get something negative. So negative 2 times 1.99 minus 3 times 1.99 plus 1 over 1.99 minus 2. So again, negative 2 stays negative. 1.99 minus 3 would be negative. 1.99 plus 1 be positive. And in the denominator, 1.99 minus 2 would be negative. So on the top, I have a negative times a negative, which is a positive, times a positive, which remains positive. And in the denominator, I have a negative. So a positive divided by a negative gives me a negative. So my assumption here is that my graph on the left side of the vertical asymptote, so right here, would be going off to negative infinity, which again is kind of what we assumed. So I'm going to skate very close to my slant asymptote, going through my x-intercept and my y-intercept, and then down to infinity. There we go. And there's my graph with the slant and the vertical asymptote.